Through the process of building this home, part of the design of the home was to build it green on a budget. Every component of the build was based on a value. How much are they going to save us on an annual basis versus how much are they going to cost us on a 25-year mortgage? And if they put us cash flow positive, they got put into the home. We didn't go all out on the finishes. We can upgrade those things down the road, but your walls, you're never going to change them.
Rodney Penner and his young family recently moved into their forever home. After having some problems with houses in the past, it was important to Rodney that this one would provide a healthy living space for his children and be cost-effective not just now, but for many years to come.
We've lived in some homes where there was mold issues, so building out of materials that don't rot or contribute to molding or off-gassing was important. And being able to build a home that we can afford today, but also afford 20 years down the road as well. We just got the first energy bill on the meter, and January being the coldest month of the year was substantially lower than even our equal billing payments on the last house we were in.
So, what's the secret to these energy bill savings? Rodney's home was constructed using ICE panels, a composite building envelope system that is pre-engineered and designed to provide high insulation values and eliminate thermal bridging.
The panels are made out of two primary components, EPS and G90 galvanized steel framing. Once you stand the walls, your insulation's in place, your vapor barrier's in place.
ICE panels are designed and manufactured by Greenstone Structural Solutions in Brandon, Manitoba, Canada.
Everyone wants a home that's going to last. The problem with wood construction is you aren't able to pass on homes as effectively to the next generation because of the life cycles. Greenstone is different that way. It has a much longer life cycle. It performs much better during that life cycle because it has very high R values and no thermal connections.
It's not a difficult learning process to learn how to build with Greenstone. Every panel has its individual number. You just follow the installation instructions, you put the panels where they belong, make sure you seal it up as per the instructions, and you'll have a super airtight, super efficient building envelope.
If we're to build a house like this out of more conventional materials to get to the level of insulation and thermal break that we have with the ICE panels, we would have spent more money than we spent using the ICE panel product to get there.
Rodney knows that by using Greenstone's ICE panels to build the envelope for his home, that his walls are highly insulated and have no thermal connections. But today, the home's energy performance is being put to the test.
Gio from Prairie House Performance was down here today. He was doing the EnerGuide certification on this home.
We specialize in residential building performance. We help people to build or create homes that are more energy efficient, are more comfortable, have better indoor air quality, are more resilient, and are more durable. One part of our business is providing EnerGuide rating system evaluations.
An EnerGuide rating is an official record of your home's energy performance.
So testing things like overall air tightness performance, trying to verify that this house was built according to the plans and also that it's performing according to its calculations.
That seems to be pretty airtight. Okay, so what we're going to do now is we're going to set up the blower door for the air tightness test. It was the first time where we had been able to test a house that was built with Greenstone from top to bottom.
The air tightness test will be done with a blower door, which uses a fan to depressurize the home.
So now we're sucking air out, and you can see this on the left-hand side. This is the house pressure, and this is the fan pressure. Essentially, we're going to be measuring difference in house pressure with relationship to outside and the airflow through the fan. And then our software is going to tell us how big of a hole there is in the house if we add together every little crack and gap and hole.
After numerous pressure readings, Geo is ready to punch the numbers into his software and get the final results of the air tightness test.
Nice.
0.34.
Right on.
Congratulations. That's really good.
The most stringent residential energy efficiency program in the country is Passive House, which requires an air tightness of 0.6 air changes per hour or lower.
But today's test on this house, we had results of 0.34 air changes per hour at 50 pascals, meaning that we exceeded the Passive House target by almost 50%. It was among the top 8 or 10 tightest houses we've ever tested. From an energy standpoint, we know the building is going to use 40 to 50% of the amount of energy a similar size house built to code would consume.
We did find a couple little areas that we will be addressing, but nothing significant. Overall, we were very impressed with the final result.